Hello students, this is Karthik, your maths tutor, heartily welcoming you all to Vista's Learning. What is Vista's Learning? Vista's Learning is an online education platform where we strive to deliver quality education for all. In a previous class, we had stopped in the third chapter of class 12 mathematics, that is matrices. So this is the very last session of that. After this, we'll be completing the synopsis of matrix and we'll be moving on to the NCERT questions. So for today, the last topic is invertible matrices. So inverse of a matrix, I think we have seen that in the previous class, elementary row transformations. So what are invertible matrices? If a square matrix of order m and if there exists another square matrix B of the same order, now there is a matrix A of order m and there is another matrix B of order m again, same order, okay, such that, see this line, AB equals BA equals I. What is I here, students? I here is nothing but identity matrix. Matrix multiplication between A and B, matrix multiplication between B and A, if both of them are giving the product as an identity matrix, then B is called as the inverse of matrix A. Correct. Now for example, so this is matrices, right? We'll take in terms of example, students. See here, if 6 is a number, what is inverse of 6? 1 by 6. Correct. So this will be equal to what? 6 and 6 will get cancelled. We'll be getting 1. Same thing here, but I, which is nothing but identity matrix. Okay. So B is called the inverse of matrix and is denoted by A inverse. In that case, A is said to be invertible. Understood? So same thing, 6 into 1 by 6, 6 and 6 will get cancelled, we'll be getting A here. In the very similar manner, A dot B, okay, so what is B equal to, students, here? B is nothing but equal to A inverse. Where is that written? See here, denoted by A inverse. So B is equal to A inverse means again this can be written as A into A inverse, which will be equal to I. In such case, A is said to be as what? A is said to be as an invertible matrix. Understood? So this is nothing but invertible matrices. One small example we'll take here. So example, we'll take two matrices A and as well as B. Matrix multiplication will do. We'll see whether AB and BA both are equal to I. So first we'll take AB on the left hand side. So A dot B. This can be written as 2, 3, 1, 2. What is the order here, students? 2 cross 2. And what is matrix B? 2 minus 3 minus 1 and 2. Minus 3 minus 1 and 2. What is the order here? Same thing, 2 cross 2. Now what is AB equal to? Matrix multiply them. How do we matrix multiply? Can we multiply number of columns is equal to number of rows? Yes, we can multiply. What would be the order of product? 2 cross 2. So here we'll write the order of the product will be 2 cross 2. Now matrix multiply them, students. How do we multiply the matrices? By column first row into first row into second column. So see this, first row into first column. 2 2s are 4. 3 into minus 1 is minus 3. So 4 minus 3 is 1. Correct? 1. Next, first row into second column. Minus 6 plus 6, 0. Second row into first column, 2 minus 2, 0. Second row into second column, minus 3 plus 4 is 1, which is equal to I. So therefore what we can tell? B is the inverse of A. So that is nothing but we can tell that A is invertible. So this was what, students? A into B, right? On this side we'll do B into A. So B dot A. So B matrix first, 2 minus 3 minus 1 and 2, and A matrix 2 3 1 2. Same thing, same order, 2 cross 2 2 cross 2. Product also will be equal to 2 cross 2. Matrix multiply them, row into column again. BA will be equal to, so first row into first column, 4 minus 3 1, 6 minus 6 0, minus 2 plus 2 0, minus 3 plus 4 1, which is again equal to I. So we just now proved whatever we have seen in the invertible matrices, correct? So moving on to the next one. What do we have next? Theorem. So there is one theorem under invertible of matrices. So this theorem is belonging to invertible of matrices. Okay. So see the theorem, uniqueness of inverse. Inverse of a square matrix, if it exists, is unique. Okay. Inverse of a square matrix, if it exists, then it is unique. So for example, let us take here, if A is a matrix given by Aij, B and C. So comma will put here. Okay. A is a matrix, is given like that. B and C both are inverse of A. Okay, B and C both are inverse of A. Then what can we prove here? We should show that B is equal to C. This is what we have to show. So that is nothing but inverse of a square matrix. If it exists, it is unique. B is equal to C. Okay, so how do we start with this one, students? So here we'll start with A dot B is equal to B dot A is equal to what? So what is B, students? B and C both are inverse of matrix A, right? So what did we see previously here? If B is the inverse of A, AB will be equal to what? I. Correct. So here A dot B or B dot A will be equal to what? I. Similarly, C is also the inverse, which means A dot C is equal to C dot A will be equal to what? I again. Correct. So now what we'll do here, students? A dot B is equal to B dot A is equal to I. This we have written. We have to show that B is equal to C. Okay. A dot C is equal to C dot A is equal to I again. Now if B is equal to, so A, B, B. So B is equal to what here? So students see this. A dot B is equal to I, which is equal to what? C dot A. So from here can we tell that B is equal to C? Is this correct? B is equal to C. So that is what we had to prove in this theorem, and that has been proved. Apart from this, if you take the inverse of A on another hand, so this is also right hand. A dot B is equal to B dot A is equal to I. Now let us only consider AB is equal to I. Same thing, I can again be written as CA. AB is equal to CA. Same thing, A will be equal to, B will be equal to C. Inverse of a matrix. So one theorem. Under theorem 1 we can take this. Okay, under invertible matrices. The next one. Next theorem. So if A and B are invertible matrices of the same order, then again we have to prove this. AB the whole inverse is equal to B inverse into A inverse. To start with this proof. So what do we know already? A dot A inverse is equal to I. So similarly we can write, students, AB dot AB the whole inverse will be equal to, on the right hand side we'll write, okay, so this will be equal to I again. This will be equal to I. Correct. Same thing, A inverse is equal to I. So here we'll do one small operation, multiply with A inverse on both sides. So once you multiply A inverse on both sides, what will happen? A inverse into AB into AB the whole inverse is equal to I dot A inverse. Now see the students, okay, we'll put the brackets here. This can be written as what? This can be written as what? I, correct? A dot A inverse or A inverse into I will be equal to I. So this can be written as I, continuing with the red color again, B as it is, dot AB, the whole inverse is equal to A inverse. Understand it? So I into B will be equal to what, students? I into B will be equal to B only, because see what is I here? I is nothing but 1. And what is B? B is nothing but some number. Okay, in terms of numbers, if we see 1 into 3 will be equal to how much? 3. So very similarly to this, IB can also be written as what? B dot AB the whole inverse is equal to A inverse. So again here we'll take multiply B inverse on both the sides. So once we multiply B inverse on both the sides, okay, we'll change the color here again. Once we multiply B inverse on both the sides, what will happen? So here we'll write B dot B inverse of AB the whole inverse is equal to B inverse into A inverse. See this result, students, B into B inverse. Similarly we had here, right, A inverse into A. So this will be equal to how much? I again, so that is nothing but, on this side we'll write I into AB the whole inverse, which will be equal to B inverse into A inverse. So finally we can write AB the whole inverse is equal to B inverse into A inverse. So this is another theorem. So students, these theorems, only the proofs are important. Okay, the proofs are important, means this you have to remember here. This proof will not be asked in the examination. I'm just solving this for you here. Apart from this, in the previous slide also, so uniqueness of inverse. So this statement is important. There is no formulas here. Okay, you have to just remember the statements. Proofs are not important. This is just for the class to make you understand, students. Here also the same thing. This result is important. You can just make a note of this, and the proof also you can make a note, but this will not be asked in the examination. Okay, what you have to remember here is, this is what you have to remember. Understood? So now the very last thing what we'll be seeing is finding out the inverse using elementary row transformation. So this we have done in the previous class also. We'll do a bigger example this time. So whatever method we are going to follow in this, okay, so I'll go very slowly here. Try to understand, okay, also try to implement the same method in your examination. So this will be asked for around some 4 marks, okay, 3 to 4 marks. So the method which we are going to see right now here in the class, okay, try to implement the same method in your exams. You will be getting full marks without any doubts. So the example which we have taken here is obtain the inverse of the following matrix using elementary operations, and the matrix is given like this. Okay, so we'll write down the matrix here. Matrix A equals 0, 1, 2, 1, 2, 3 and 3, 1, 1. So students, see this. We have to find out the inverse of A. How? By using elementary operations. So what do we know already? We know this, right? A dot A inverse is equal to I. This result we know. Okay, send A inverse on that side. What will happen? A is equal to I into A. Correct? So this we will write it in the form of matrix now. This thing. Okay, so this is your very first number 1. What you have to write? A dot A inverse is equal to I. A is equal to I into A. After this, what is A, students? 0, 1, 2, 1, 2, 3, 3, 1, 1. What is I? Identity matrix 1, 1, 1, 0, 0, 0, 0, 0 and 0 as well. And A as it is. Okay. So now what is our aim, students? What did we see in the previous class? We have to get this identity matrix on this side. But how do we get it? By using elementary row operations. Now students, see the very first element. Here we have 0 and here we have 1. Correct. So but here we need 1, right? So this you have to get it on this side, means this 1 must be present here. But 0 is present there. So what is the elementary operations that we can operate here? So here you can take R1 getting interchanged with R2. What happens? If R1 gets interchanged with R2, what will happen, students? So this R2 will go in the place of R1. So that will become 1, 2, 3, 0, 1, 2, 3, 1, 1. So this will be equal to same thing 1. So here also R1 getting interchanged with R2. So this R1 is getting interchanged with R2. So this R2, students, will go to in the place of R1. So that will become 0, 1, 0. This will become 1, 0, 0, 0, 0, 1. Did you understand this step? Students, to find out inverse, okay, we'll be using which identity here, A dot A inverse is equal to I. Okay, A inverse will send it on this side, A is equal to I dot A. We'll be substituting the matrices now. A matrix is written as it is, I matrix is written as it is. Now students, to find out the inverse, what I have told you in the previous class, you have to get the identity matrix which is on the right hand side to the left hand side, correct? To get it on the left hand side, how do we get it? By using elementary row operations. So if you see on the left hand side we have 0, right, but we needed 1 here. You cannot write R1 plus 1, okay, that will be wrong. So what are we doing? We are interchanging the rows. R1 is getting interchanged with R2. So the same operation is applicable to this as well as this. So once we apply this, see on this side now, we got 1 here, and this also same row transformation is applied, and A is written as it is. Okay. So this is already 0. This is already 0. So we have to get a 0 here, correct? So to get 0 there, we'll change the color again. What can we write, students? Which row operation? R3 is equal to R3 minus 3 times of R1, correct? R3 minus 3 times of R1. Students, R3 is only getting changed. R1 and R2 are as it is. So R1 and R2 you write it as it is, 1, 2, 3, 0, 1, 2, which is equal to 0, 1, 0, 1, 0, 0. Whenever you are finding inverse by elementary row transformation, the very first thing what you have to do is, you have to get 1 here in this place. Okay. How do you get 1? Sometimes what you have to do, students, if suppose there is 9 here, if suppose there is 9 given, okay, here also let us take some 7 is given and 3 is given. Now you have to get 1 here, right? How do you get? You have to do R1 equals R1 by 9. Understood? R1 equals R1 by 9. This operation must be done if there is 9, 7 and 3. Now what do we have actually? 0, 1, 3 we have. So we interchanged. So we came up to this operation. If there was no 1 here and there was some other number and there was some other number here, then you can get 1. So always the very first step what you have to remember is, the very first element, that is A11, should be equal to 1. This is your very first step. So see, this is your first step I have written. Second step, A11 should be equal to 1. Once you get A11 is equal to 1, which has already happened here. So this is followed by 0. Now you have to make this 0. So this column we are completing or making it as an identity matrix column. Okay. So R3 minus 3 R1, 3 minus 3 of 1. So 3 minus 3 is 0. Write 0 here. 1 minus 6 minus 5. 1 minus 9 minus 8. Understanding? Same thing here, students. 0 minus 0, 0 only. 0 minus 3 times of 1, that is 3. So that will become minus 3. And 1 minus 3 times of 0, that will be 1 only. Now see the students, see this column here. See this column. 1, 0, 0 we got. See the identity matrix here. So this column and this column has been matched. Next what we have to do, we already have a 1 here. We have to make this 0 and also this as 0. Okay. With respect to what? With respect to the middle term. See these both elements. Okay. So I'll just write down here. A21 comma A31 must be made 0. With respect to A11. But what is A11? See here, what is A11? A11 should be equal to 1. Step 1, step 2. And this will be your step 3. Start making down the notes or just make a note of the steps. The very first step, write the formula like this. So this will be your first step. A dot A inverse is equal to I. A will be equal to I dot A. Substitute the matrices. Second step, A11 you have to make it as 1. How? Sometimes by interchanging the rows or sometimes by using this operation. Understanding? Okay, once A11 is 1, what you have to do next? A21 and A31 must be made 0 with respect to A11. That is also done. So 3 steps are done, students. Next, what is the fourth step? Now, with respect to which element is this? A22. Correct. With respect to A22, make A12 and A32 as 0. That is your fourth step. So, number 4 here will write. With respect to A22, make A12 and A32 as 0. With respect to A22, make A12 and A32 as 0. Now, how do we make these both as zeros? So, we'll do one thing. Okay, so here I have to write dot A. Okay, so we'll take this to the next slide and we'll continue that fourth step in the next slide. All right. So, next slide will start from here. 1, 2, 3, 0, 1, 2, 0, minus 5, minus 8. Zero, 1, 0, 1, 0, 0. 0, minus 3 and 1. Okay, now A22 is 0. We have to make these both as 0, right? With respect to A22. So here we'll write R1 is equal to, two operations we'll write together, students. Okay, R1 is equal to R1 minus 2 times of R2 and R3 equals R3 plus, so to make this as 0, 5 times of R2. Apply both the operations together on both the sides. So what will happen? This and this will become 0. We'll see what we'll be getting on the right hand side. So what will happen, students? So R1 and R3 getting changed, which means R2 is untouched. Means that will remain constant. So open the brackets, write down the matrices 0, 1, 2. The second row, which is equal to 1, 0, 0. What will become for R1 now? R1 minus 2 R2. R1 minus 2 R2, it remains as it is. R1 minus 2 R2, 0. R1 3 minus 2 R2 minus 4, it will become minus 1. Okay. Same thing. R3 plus 5 R2, 0 plus 5 R2. So that is 0 only again. R3 minus 5 plus 5 times of R2. So that will become 0 again. Minus 8 plus 5 into 3. Minus 8 plus 15. Minus 8 plus 15 will be equal to 7. So on that side we got. On this side what will be getting, students? R1 minus 2 R2. R1 minus 2 times of R2. So this will become minus 2. 1 minus 2 into 0. 1 only. 0. So this will become 0. R3 plus 5 R2. 0 plus 5. So that will be 5. Minus 3 plus 5 into 0 is minus 3 only. And here 1 plus 5 times of 0 is 1 only. Here we have A again. Now see this, both the rows have become equal to identity matrix 1, 0, 0, 0, 1, 1. Now we have the last row, right, students? Last column, sorry. We have the last column. Before we start with the last column, again what you have to do here, next step. The next step what you have to follow here is make A33 is equal to 1 and with respect to A33, make A13 and A23 as 0. This is your last step. So which step would be this? So this would be step number 5. That's all. If you follow these 5 steps for any given matrix to find out the inverse, okay, you can easily find out the inverse of the matrix by using elementary row operations. Now how do we make this as 1, students? A33 is this element, right? How do we make that element as 1? How do we make that element as 1? Row transformation again. Here we'll write R3 equals R3 by 7. Simple. R3 equals R3 by 7. What will happen? So R1 and R2 are untouched. So that will remain constant, it will be as it is, correct? So minus 2, 1, 0, 1, 0, 0. Here we'll write 1, 0, minus 1, 0, 1, 2. So R3 by 7, 0 by 7 is 0, 0 by 7 is 0 again, 7 by 7 is 1. Okay, 5 by 7 as it is, minus 3 by 7 again, and 1 by 7 into A. Now R3 is 1, right students? So this is done, this step is done. And with respect to A33, make A13 and A23 as 0. With respect to A33. So now, the next operation what we can write here is, we'll change the color again. R1 equals R1 plus R3, correct? Minus 1 plus 1, 0. And R2 equals R2 minus 2R3. So 2 minus 2 will again become 0. So here we got what students now? Identity matrix. On this side you have to apply the operations now. R1 and R2 means R3 is constant, 5 by 7, minus 3 by 7, 1 by 7. R1 plus R3, minus 2 plus 5 by 7. So here we'll write minus 2 plus 5 by 7. So this will become minus 14 plus 5 by 7. Minus 14 plus 5 is nothing but minus 9 by 7. Here we'll write minus 9 by 7. Next, 1 plus 3 by, or 1 plus of minus, so that will become 1 minus 3 by 7. So what is 1 minus 3 by 7? 4 by 7. 4 by 7. Next, 0, so this will become 1 by 7 as it is. R2 minus 2 R3. R2 is 1 minus 2 times of R3. So it will become 1 minus 10 by 7, correct? 2 times of R3. So that will become minus 3 by 7 there. Minus 3 by 7. 0, so it will become minus 6 by 7, and this will become minus 2 by 7 into A. Rewrite this, whatever we have got here. So this can be written as what? I. 1 by 7 we can take common. 1 by 7 of, write down the elements, minus 9, 4, 1, minus 3, minus 6, minus 2, 5, minus 3 and 1 of A. Send this A on that side, students. What will happen? If you send this A on that side, you will be getting A inverse into I, which is equal to the matrix. A inverse into I is nothing but A inverse only. So finally A inverse can be written as 1 by 7 of minus 9, 4, 1, minus 3, minus 6, minus 2, 5, minus 3 and 1. So this is your A inverse. So students, getting the answer is okay. So that is not a problem. But what you have to understand, or what is very important in this problem, is you have to follow these 5 steps as it is. If you follow these 5 steps, okay, getting inverse will become very, very easy. So we'll just summarize the steps again and we'll be stopping the class. Alright. So see here, the very first one, the very first step is always write down this first. The identity A dot A inverse is equal to I. Send A inverse on that side. A is equal to IA. Once you have written this, after this what you have to do? Substitute. So this is your substitution. After substitution, what students? Always make A11 is equal to 1. Basically you are making the principal diagonal as unitary. So with respect to that principal diagonal, other elements are becoming 0. So A11 is equal to 1. Once you make that as 0, the other 2 elements A21 and A31 must be 0 with respect to A11. Step 3. Similarly, next is A22, you make it as 1. Okay. A22 must be make it as 1, and A12 and A32 must be 0 with respect to this A22. The last step is okay, one second. The last step here is A33 must be made 1. Okay, with respect to A33, make A13 and A23 as 0. So if you make this as an identity matrix, whatever matrix is remaining on this side, so that will be the inverse of A. So that is all for today, students. So this is the very last topic. In the 3rd chapter of class 12 matrices, we'll be starting with our NCERT problems in our next class. Thank you, students.